Having reviewed the general structure of the hypothesis testing, it's time to start doing the hypothesis test, right? And filling in those little details of like, okay, how do we get this p-value? And then kind of reinforcing how to make decisions is here as well. So we're going to start with the test where we know the population mean. So we have a one population scenario. We are interested in the mean, and we have then I guess then we're going to be forced into the one sample t or z test. And we're going to focus on the z test. Next chapter was 16, I think it's actually called, is where we do the t test. So we'll differentiate between the two. And so let's get started. So for a z test, right, one sample z test, we have to have one population of interest. We're looking at the mean, and actually there's a few more conditions that we need to satisfy. We have to make sure that the observations we obtain, the xi's, are IID, independent and identically distributed, that the population that we are pulling from is normally distributed. And then I guess before I move on to condition 3, the textbook calls those conditions 1 and 2 together as simple conditions. So if you see the language of simple conditions, that's what it refers to. And most importantly for the z test, okay, the third condition is that we have to know the population standard deviation. That's actually how we distinguish between a t and a z. So if we have if the population standard deviation is known, then we're going to use sigma. Okay, and so then once we say, okay, we have all these, the conditions for the z-test is met, that's always critical, then we can go on and formulate our null and alternative hypotheses. Okay, and that's very much the same as what we have seen. Here I just put mu0 in as that number, so just think of mu0 as a number. I call that the hypothesized, so the hypothesized size, spelling, mean value. So for instance, if we think about body temperature, right, oh wow, terrible handwriting, I apologize. If we think about body temperature, right, we commonly think of body temperature as 98.6. So in this case, my mu naught would be 98.6 if I were to do an experiment with body temperature. But nevertheless, alternative has one of those three forms. And then now here, in going forward to calculate the p-value, right, there's always this gap between hypotheses and p-value. What we're going to do is we're going to calculate a test statistic. So before we can get the p-value, we need to get a test statistic, and that's this value of z. Okay, and oddly enough, if you think about this, you've seen this before. This is just the z-score. Okay, so for the z-test, we need to calculate the z-score. Okay, and then with the z-score known, then all we have to do is calculate p using, well, the z-score follows a standard normal distribution. Use that to calculate the p-value. So p here, the p-value is just going to be the probability, and how we calculate the p-value is based on the direction of the direction indicated in the alternative hypothesis. So if we go to the left, we're going to do just norm.dist, right? And then our z-score 0, 1, true. If we go to the right, then we have to do the 1 minus, just as we did before. Okay, the new case for us is if we have not equals. Okay, this one, I don't know how to explain it better than, you know, to do 1 minus. Maybe the diagram will help you. So if you think about the normal distribution, okay, right, and you calculate a value, so this is 0, and then maybe you get your z value here, right? You are looking for the symmetric area. So here's z, and here's minus z, okay? The p-value would be the direction from z towards, or from z and minus z to the end of the tails, okay? So to help you calculate both of these areas, what we do is we calculate one of them and double it since it's symmetric. So I'm doing the upper part, so I would do 1 minus norm.dist. So this part in here would give me this tail, and then I just multiply by 2. Okay, so 1 minus norm.dist, and then I do the absolute value just in the case that z is negative, so I would move it over here and do that. If you want to set up a similar calculation for this one and then do twice that, hey, you'll get the same thing. Okay, so these are very much in line with our past knowledge of the standard normal distribution. Okay, so if we got a z here, we would go to the left. If we got a z value over here, then and we wanted to the right, we would do the 1 minus. So consistent with what we've learned with the normal distribution. Okay, so with all that in mind, let's do this. Okay, so we're going to set up our hypotheses, calculate a z test statistic, and then use that to calculate our p-value and make a decision. Okay, so here we go. I'll let you read through the example, resume the video when you're ready. Okay, so we want to set up our null and alternative hypotheses. Okay, I know there's going to be a mu. I need to define what mu is. And the idea here is that the mean here should be describing the average sodium intake for adults and adolescents. Okay, so in the null hypothesis, we're claiming that the mean is equal to something, and then, let's see, does this finding suggest do not consume the recommended amount of sodium? So do not consume, I'm going to say is different from, so I'm going to use different from here. And now there's a whole crap ton of other numbers here, and I think before I move on, I should probably identify them, right? I have the 2300, I have the 800, I have 272, and I have 2486. Okay, so I would like to give a symbol name to each one of these. Can you do it? Try it. Okay, and if you did it, you should get that the 800 is sigma, n, our sample size is 272, and the mean for the sample, which is x bar, is that. So then what is 2300? Is that mu? Actually, so this is the hypothesized value of mu, so mu naught. Okay, that's what we think is the mean, and that's what we're testing. So that's going to go in my null and alternative hypotheses. Okay, great. So now let's see, I'm reviewing what we did before. Okay, so I got my, okay, get my z test statistic. Okay, so z is going to equal x bar minus mu. This is actually mu naught, our hypothesized mean value, and then sigma over square root of n. Okay, so then 2300 minus 2486 all over 800 divided by 27 or square root of 272. Okay, so now I get my calculator out and do this. But first, it would help if I put the numerator in the right order. So let's put it in the right order. 2486 minus 2300. All right, now we can calculate. And so when I calculated this, I got about 3.834. So, okay, just thinking logically, this is almost 4 standard deviations from the mean. This is the probability here should be pretty small. Okay, so to calculate the p-value then, since this is a two-sided test, right, I need to do, right, two-sided, so I need to do the 2 times parentheses 1 minus norm dot dist, and then 3.834, and I would take the absolute value of it, but well, it's already positive, so it doesn't matter. And then 0, 1, and true. Put that into Excel and get out a number. And when I did this in Excel, I got 0.000126-ish. Okay, and so then in terms of kind of wrapping this all up, if I look at P, which is 0.000126, and compare that to alpha, which, what is my alpha value? Oh, they don't say. So we get to choose. Okay, and the default value that we choose for alpha is 0.05. Okay, so if we compare this to 0.05 or 5%, well, p is much less than alpha, and so here I would reject the null, okay? And so I always want to do a little concluding statement. I would say, since p is less than alpha, we reject the null hypothesis. And then I always like to interpret this in context. So this means that there is evidence that, and then I'm going to state the alternative hypothesis. So that the average sodium intake for adults and adolescents is different from 2300. And there we go. Okay. So again, big hallmarks here are that we had to set up the hypotheses, right? Mu is equal to a number, mu is not equal to a number in this case because we were saying that we were asked the question, does this suggest that they do not consume the recommended amount? We're not given more or less. Identified all the values, calculated our test statistic, calculated our p-value based on the test statistic and the alternative hypothesis, made a decision, and interpreted it. Okay? 4 big steps whenever you encounter a hypothesis test problem.